Okay, so in your warm-up today, I asked you to draw a Bohr model for the following elements and then write the number of protons, neutrons, and electrons found in each one. Okay, so this should be review. On Friday, you're going to have a quiz, and you're going to have to do this, and then you're also going to have to do the Lewis dot diagram as well, and you're going to have to find the PNE, which is the proton, neutron, and electron. So we're going to learn Lewis dot diagrams today, and we're going to review over Bohr model just to make sure that you guys understand what you're doing, okay? So the first one we had was helium. And what's the first thing that you should have out in front of you anytime you are doing anything that has to do with the elements? Destiny. Your periodic table of elements. Remember, I told you that that was like the most important piece of paper you were going to get all quarter, and that we use it quite often. So what's the first thing I need to do when I am drawing a Bohr model? What's the first thing I have to do, Johnny? What are those letters called? The symbol, okay? So what was the symbol for helium? Capital H, lowercase e. Okay, just like that. That's the first thing you should have done. Then what do you need to do? Damon. Nope. What do you have to do, Destiny? You have to find out what period it is, because depending on the period that it's in, it tells you how many what? How many what, Kevin? Energy levels. So what period is helium in? Period 1, which means it has how many energy levels? 1. So you would draw a circle just like that. Okay? Now, what are we supposed to put on that energy level? Or any energy level? What's the only thing that goes on there? Aspen. The number of electrons? Yes. So how many electrons does helium have? How many electrons does helium have, Laura? 2. So you would draw it just like that. And that's how many you should have. That's what it should look like. Okay? Then I asked you to find the PNE. I know it sounds like a naughty word, but really it's not. Proton, neutron, and electron. That's what you need to be finding. How many protons, or how many P's does helium have? How many times does it P? Eric? 2. Okay, so if I know that there are 2 protons, I also know how many, Dane? Electrons. Okay, so what do I have to do in order to find the number of neutrons? What do I have to do? Explain to me the process. Don't give me the answer. Ernesto. First, I have to round the atomic mass. So if I look at helium, what am I rounding it to? 4. It stays 4 because it's 4.000. Then what do I do, Ernesto? Yep. Okay, so I subtract the atomic number or the number of protons or electrons to give me my answer. So 4 minus 2 is 2. So helium has 2 neutrons. Okay? How many people had this or something very similar to that on their paper? Good. Raise your hand if you got it incorrect. I need to see who is not understanding. Nobody? Good. All right. So the next one, what was the next one? Aluminum. The symbol for aluminum is capital A, lowercase l. Just like that. Okay? How many energy levels does aluminum have? How many energy levels does aluminum have, Caitlin? 3. How did you know that there's 3? It's on the 3rd period. It makes me so happy when you guys are using the correct vocabulary. From now on, row and column is a science swear word. I'm going to look at you and say, stop swearing at me. Okay? Don't make me call home, because you know I will. I'll be like, oh, sorry, Justice was swearing in class today. He has a naughty mouth. Okay? So how many... Let's do our P&E first, because then that'll be easy. What's our P&E for aluminum? P&E for aluminum. What's our proton? Damon. 13. If we know our protons, we know our electrons. Okay, so what is our neutron then? What is our neutron for aluminum? Aspen. 14. How do you know it's 14? Atomic mass. Rounded near to the nearest whole number, which is 27. And then 27 minus 13 is 14. Good. Okay, so how many electrons am I putting on my Bohr model? 13. Okay. How many electrons are allowed to go on the first energy level? 2. Whoever said 4 needs to study. Okay. 2 go on the first energy level. How many are allowed on the second energy level? 8. Okay. How many are allowed on the third energy level? Allowed. 8. How many are actually going on there? 3. Because 3 plus 8 plus 2 equals 13. Okay. It should look like that. Last one was neon. Okay. How many energy levels does neon have? 2. How do we know this? It's in the second period. Okay, how many electrons? Oh, let's do our P and E. Okay. Laura. How many protons? 10 protons, which means there's 10 electrons. And how many neutrons does neon have, Jewel? How many neutrons does it have? Jakari. Okay. Ernesto. 10. Because 20 minus 10 equals 10. Okay. Neutrons. Okay. You did the wrong one. I should hope so. 7's kind of a wild number. Okay. How many goes on the first energy level? 2. How many on the second? 8. Jakari, which one did you do? Oh, that's not good. Okay, so that's what neon should look like. Okay, how many people got all 3 of these correct? All 3 of these correct. That's good, because when you take your quiz on Friday, hopefully you'll remember this information. So here's the question. What is a valence electron? Okay. And that's what our question is today, because in order to do the Lewis dot diagram or the electron dot diagram, you need to know what a valence electron is. How many people know what a valence electron is? Nobody even wants to take a guess? Jakari. I can't hear you. I'm sorry. Nope, not the average. That's a good guess, though. Valence electron is, and if Miss Brackney is writing it, it must be important, the number of electrons in the outermost energy level. I'll give you guys a second to write that down. Okay, so if the definition for valence electron is the number of electrons in the outermost energy level, how many valence electrons does helium have? 2. Okay, so helium has 2 valence electrons because how many energy levels does valence helium actually have? 1. So obviously it's the outermost energy level. Okay, so let's look at aluminum. How many valence electrons does aluminum have? 3, because on the outside there's 1, 2, 3. Okay? This is the outermost energy level. You know it because it's on the outside. Get it? Outer energy level, outside. Okay. And then we look at neon. And how many valence electrons does neon have? 8. Okay, now, if you really wanted to know the valence of electrons of each element, you could always, draw the Bohr model every time. Or I could teach you how to do it on the periodic table very easily. How many people want to know the easy way? This guy. Johnny is this guy. Okay, so if we're looking at the periodic table of elements. Okay, I'm trying to fit it all in there. It's running slow today. Okay. What does the number that runs along the left-hand side tell us? The number of what? This is the period number. What does it tell us? The number of, Dane? Energy levels. So remember I said every element in row 1 has 1 energy level. Every element in row 2 has 2 energy levels, and so on and so forth. Now we have the same process when it comes to valence electrons, except for this part in here. Do you see this part that I'm pointing to? The hole? It's like the hole of the periodic table. Do you see it? It kind of dips down really far. These are called the transition metals. So this rule that I'm about to tell you doesn't apply. Okay? But if you look up here at the top of each column, what are these called again? Does anybody remember? Families or groups. Okay, good. Do you see the number at the top where it says 1A, 2A, 3A, 4A, and so on and so forth? That number with next to the letter A tells you how many valence electrons those atoms have, or those elements have. So we did helium, right? Oh, well, we're going to skip over helium because that's going to be the bonus question. But the aluminum right here, how many valence electrons did aluminum have? How many valence electrons did aluminum have? 3. Look, right above here, 3A. That means every element in this column has 3 valence electrons. Okay. How many valence? So we're going to do a little quiz for you, Jolly Rancher quiz. So if you get it correct, then you get to come up here because we're trying to record it. How many valence electrons does potassium have? How many valence electrons does potassium have? Dane. No. Yes. Sorry. Yes. Yes. So it has 1 valence electron, so you can come up and get a Jolly Rancher. How many energy levels does potassium have? How many energy levels? Destiny. 4. Yes. Okay. How many energy levels does carbon have? How many energy levels does carbon have? Gavin. 2. Yes, because it's in the second period. Come on up. How many valence electrons does carbon have? Valence electrons does carbon have? So, I can't see because it's beyond Johnny. Shelby. 4. Yes. Good. Do you guys understand the concept now? Okay. No, there is a bonus question. This one is good for 2 Jolly Ranchers. Okay. How many valence electrons does helium have? How many valence electrons does helium have? Ernesto. 2. Why is it 2? Yeah, there's only 2 electrons on helium, but it's in the 8th column, right? How many of you raising your hand thought the answer was 8? Okay, that's okay because that's why I asked you. Ernesto, you can get your 2 Jolly Ranchers. So here is the 3 Jolly Rancher question. Are you ready? Why, if helium only has 2 valence electrons, is it in the column where all the rest of them have 8 valence electrons? Why is helium in the 8th column if it only has 2 valence electrons, according to the rule that I just gave you? Caitlin. No. Good guess. Not because it's in its first period. Why does helium belong in the last column if it only has 2 valence electrons? No takers, huh? I guess that means I get the 3 Jolly Ranchers. Johnny. But what does that mean? Okay. It's in, so I guess I'm the 3 Jolly Rancher person. Nope. Okay. It is here because I want you to look at these drawings right here. Compare helium and neon. What do they have in common? Take a look and think about what they have in common and why they both belong in the 8th row. Andre. I'm sorry, I can't hear you. No, they don't both have an E. Okay, that's not what we're looking at. Shelby. No. Okay, I'm going to tell you. Is this energy level full? Yes. Is this energy level full? Yes. Every element that is in this column right here, their outer shell or outer energy level is full and cannot take any more electrons. That is why. Oh. Okay.